Right, welcome to the last MQ session. Feel free to ask questions via the chat. I'm sure Graham will take them as they arrive, or I can let him know. And it's over to you, sir.
Okay, thank you, Mel. So this is the final session, final MQ session in this year's conference. And my name is Gwydion and I work in the MQ development team at IBM Hersley normally. And amongst other things, I'm also the development lead for MQ Internet Pass-Thru. And this is something that's been around for quite a few years now, but there's been some changes to do with MQIPT, as we normally call it, in the last year or so. So that's why I wanted to do this presentation to essentially update you on what's been going on here, as well as maybe introduce some people to IPT for the first time. So feel free to ask questions in the chat at any point during the presentation. I suppose if I was in the room with you as well at this point, I would ask how many people have actually got experience of using IPT already, but I guess that's the bit that we can't get with this remote conference, that sort of interaction. So I'll start off with a bit of an introduction about what IPT is. So essentially, it's a tool for connecting your MQ endpoints together. By that, I mean connecting clients to queue managers and queue managers to queue managers. But it allows you to do that it allows you to simplify the way they do that, essentially. It doesn't let you do anything with regards to messaging that you wouldn't be able to do anyway without IPT. So your applications still send and receive messages using MQ exactly as they would without IPT being in the picture. But when you've got a queue manager and a queue manager, or a client and a queue manager connecting to each other over a network, and going in between different networks, maybe over the public internet as well, then IPT might be able to help you connect those endpoints together easily, or more easily and securely as well. So I mentioned that it's been around for a number of years. I think it might even be as old as 20 years ago or so. But of course, it's just as useful today as it was back then. And in fact, you could probably make the case that this sort of technology is more useful these days. Because if you think of the use cases where you might want to use something like IPT to connect different endpoints, or endpoints and different networks together, number of years ago, you'd have been thinking of connecting a queue manager to, on your site, to maybe a queue manager at a business partner site. So for that to happen, then you've got your MQ connection going out through your firewall, and then over the internet, and then in through your business partner's firewall, probably. That's the typical scenario where you might want to use IPT to help make that connection. But of course, these days, running things in the cloud is becoming more and more popular. So that's another scenario where you might see benefit from using IPT. So you will be maybe running a queue manager on premise and have an application in the cloud, and you want to connect the two together. So you've got a connection there going over the internet and going through one or more firewalls on the way. And of course, another scenario is that you might have your queue manager running in the cloud, and maybe you've got a queue manager running on premise as well, and you want to connect the two together. So those are all scenarios where you have MQ endpoints running on different networks, and you want to connect the two of them together. And IPT is made to help simplify, make that happen. So what is MQIPT, as in what sort of form does this product take? So I've said several times that it's been available for a number of years, but for most of its lifetime, it's actually been a support pack. So that means it's not actually part of the MQ product itself, but instead it's an add-on that you can separately download. And it was a category 3 support pack. So what that means is that it was fully supported. So if you're an MQ user with an MQ license and you had a support agreement for MQ, then you would be supported, fully supported, using MQIPT as well, and you could raise any problems, raise PMRs for any problems that you got, and get fixes if there were fixes that were needed to solve that problem. So you still got the same level of support for MQ, but still, because it wasn't actually part of the product itself, some customers didn't feel quite comfortable using it. So what happened in MQ 914, which came out, I think, near the end of last year, what's happened is that MQIPT became more integrated with MQ itself. So it is actually officially part of the MQ product itself now. However, some things haven't changed. So if you're using MQ, you're still allowed to download and use as many copies of MQIPT as you want. It's still a separately downloadable product, a separate installation, and there's a few reasons for that. And one of the primary reasons being that the places where you want to install MQIPT are often not the same places, not the same system as where you actually want your MQ installation. So it does make sense for it to be a separate download and a separate installation. It still works with all supported versions of MQ. So if you download the latest version of MQIPT, which would be 9.2 now, and that would be a good one to go for, actually, because it's a long-term service release, the most recent long-term service release. So if you were to use MQIPT 9.2, you absolutely can connect a MQ 9.0 queue manager to an MQ 9.0 client using that IPT. So regardless of which version of MQ you're using, you can use the latest version of MQIPT. So let's look at what MQIPT actually does. So it is essentially a proxy that you can use for MQ connections. And it knows a little bit about the MQ protocol that's used between queue managers and between clients and queue managers. So it's adding a little bit on top of what you would get using any sort of generic proxy that's out there. Now, in its very simplest mode, it simply listens on a TCP port for connections coming in from either a client or a queue manager, and then it forwards that connection on to its final destination, which will be eventually another queue manager, although as you see in a few slides' time, you can have multiple hops through IPT on the way. And essentially what IPT does is to simply forward that connection without the queue manager or the client knowing that there was anything in between. So it's essentially completely transparent to the endpoint. And the other thing that's important about IPT is that it doesn't store any message data as well. So it is simply a proxy that receives the data on a network port and then looks in its configuration to see where it needs to send it on to, and then just forwards that data. So you can place it, for example, in the DMZ for connections coming in or out of your enterprise. And that's somewhere where you might not want sensitive data, such as MQ messages, to be stored. And IPT actually doesn't store any persistent data at all. So it's good for placing in those sort of environments. So that was its very simplest mode that I had on the slide before, where a connection comes in and simply gets proxied on to its destination. Of course, you can do more complicated things with IPT, and this is where it starts to add a bit more value. So for example, it can accept a TLS connection that's coming in from a client or a queue manager, and it can unwrap TLS from that connection. So this is one use case that people do actually use it for. And what we're seeing now in that diagram is that you're pushing out the checks, as it were, some of the security checks on that connection out to your DMZ. So that MQIPT will now receive the TLS connection, it will check that the certificates are valid and so on, and that the connection is from a partner that it wants to be talking to before passing on that connection to the queue manager. It can also, of course, re-encrypt that data. So this is actually a very common use case that people use IPT for. A lot of customers have corporate requirements that their connections in or out to their queue managers that go in or out to the enterprise, out to the internet, need to be terminated in the DMZ. And so the TLS connection comes into MQIPT in the DMZ. The TLS connection gets terminated at that point, and then MQIPT re-encrypts the connection. So essentially makes a separate connection out of the queue manager to the destination. So that's enforcing the rules essentially that there is only one way to get into your queue manager from the outside world, and that's through MQIPT. And there's also no way that a TLS connection can go in through your DMZ without being terminated somewhere along the way. Now, I did sort of hint earlier that you don't only need to have just one IPT along the way in your connection. You can have more than one IPT if you need to do so. So it does give you more flexibility in some sort of network configurations for you to have multiple instances of MQIPT being used. We're showing pairs here, but of course you can have more than two if that's what you need, although normally you will need one or two and no more instances of MQIPT. So things that you can do here with a pair of IPTs is you can encrypt a connection between two queue managers using TLS, but you can do that completely transparently to the endpoint. So if for some reason you don't want to enable TLS on your actual queue managers, or we could equally be talking about a client and a queue manager here rather than just two queue managers. Either way, the MQ endpoints don't use TLS. They don't need to be configured to use TLS. They don't need to be given certificates and so on to use TLS. And they're also completely unaware that TLS is being used in this connection. But nonetheless, the connection is secured by IPT using TLS. So that's one other use case that you can use a pair of MQIPTs for. Similarly, you can use a pair of MQIPT instances to wrap an MQ connection in HTTP. And again, the two endpoints, the queue manager and the queue manager here in this diagram, they're again completely oblivious to the fact that the connection is being wrapped in HTTP along the way. Reason you might want to do this is that you might be taking advantage of the fact that HTTP connections are already allowed through a firewall, and so why not make your MQ connection look like a HTTP connection and use an existing route out through a firewall. Now I will mention at this point that, of course, adding a proxy such as MQIPT to the connection does add some degree of overhead. In its very simplest form of simply proxying a connection without doing very much else to it, the overhead of using IPT is actually fairly low, because remember, it doesn't actually store any data, so it doesn't need to do any I/O when it passes message data on the queue manager. Simply listening for network data, and then as soon as it can get access to a CPU to run the thread that is dealing with that connection, then it will just move that data onto the destination. So it's fairly low overhead, but of course, when you start doing a little bit more with the connection, such as adding or removing TLS to the connection, or even both, then that obviously adds a bit more overhead. So there's encryption operations and decryption operations to do with adding and removing TLS, for example. That does add overhead. And of course, the larger the number of hops that you have adds a little bit more overhead as well. So adding two IPTs on a connection will add a bit more overhead than just adding one. And the reason I'm saying this at this point in the presentation is that using HTTP is actually the worst performing method of all. So the function is absolutely there if you need it in order to solve a problem. but just be aware that you are adding overhead, and that's especially the case when using HTTP. Now, of course, there's all sorts of different combinations of features that you can use here. So with 2 MQIPTs, for instance, you can have a TLS connection between the queue manager and MQIPT, and then we can wrap that connection as well in HTTP, HTTPS in this case, because we want the whole connection to be secure. And then we can take off the HTTP wrapping in the second MQIPT and then pass on the connection in another TLS session to the final queue manager destination. So there's a lot of different things that you can do with MQIPT, very flexible, and essentially just lets you build your network in a way that is more convenient to you, or at least that is the goal. So final slide on what it can do. So we've looked at TLS, we've looked at HTTP. With HTTP, MQIPT can also use existing proxy servers. So this is where you can use IPT to essentially reuse part of your existing network infrastructure to be able to move, get your MQ connections in or out of your enterprise. So MQIPT will absolutely be able to talk to an HTTP proxy if it's doing a HTTP connection. So that's reusing an existing HTTP proxy to probably go out of your network. And also you can use a SOX proxy. So it'll be able to talk to the proxy and tell the proxy where the connection needs to go to its queue manager and the destination. So let's look at how MQIPT knows what to do with the connection that comes into it. This is where we introduce the concept of an MQIPT route, and a route for IPT is linked to a specific port that MQIPT listens on, and the route definition needs to have at least the things that we have up here on the right-hand side of the slide. It needs to be given a listener port, so that's the port that MQIPT is going to be listening on for connections coming in. And then it also needs to be given a destination host name and port number, and those are the destination host and port that IPT is going to send that connection on to. So as you can see in that diagram, we've got a connection from the client coming into IPT at port 1815, and then route 1815 in IPT knows that it needs to forward that connection onto queue manager 1 at port 1414. Now, note that the client is connecting into IPT. It's not connecting to the queue manager host name. So the con name for the client, the connection name for the where the client is connecting to, is going to be the host name of IPT and the port that IPT is listening on that route, not anything to do with the queue manager. And now this is a very simple route definition. That route doesn't do anything apart from move the data on to the queue manager. You can create more complicated routes if you want to take advantage of features like TLS or HTTP and so on. So once a client or a queue manager has connected into MQIPT using a route, then that data can flow in both directions. So what I mean by that is that when a client, for example, connects into a queue manager going through IPT, then the connection will happen, and then that client will do a number of MQI calls, presumably, to that queue manager. So we could do an MQ get to the queue manager to get a message off a queue, and he will be able to get that message from the queue. So the message data will be sent from the queue manager to the client, even though it was the client that actually initiated the connection through MQIPT. So that's what I mean by the data can flow in both directions, just as it would if the client had connected into the queue manager without MQIPT being in between the two. Now, that doesn't mean that you don't need a different route for sender and receiver channels. So if you have two queue managers connecting to each other and you want the traffic to go both ways, then you will need a sender channel defined on one queue manager and an equivalent receiver channel defined on destination queue manager. And if you want the connection, the data to flow both ways, and this is without MQIPT being in the picture, you will need an equal and opposite, essentially, pair of sender and receiver channels for the data to flow the other way. And in pretty much exactly the same way, you need two routes in MQIPT as well, because remember, a route definition has a specific destination written into the MQIPT configuration. So in this diagram, you've got two routes defined so that those two queue managers can send messages in both directions between the two. We've got route 1415 so that the queue manager at the bottom can send messages up to the queue manager at the top using a pair of sender and receiver channels. And route 1416 lets the two queue managers communicate in the reverse way. So let's look at some reasons why you would want to use MQIPT. Actually, this slide is, rather than giving you a reason why you would want to use MQIPT, it's essentially telling you where you can use MQIPT and why it's okay to use it there. So a place that customers often use MQIPT is in the DMZ, so connections that come into the enterprise or maybe go out through the firewall out to the outside world. Now, of course, you probably want to be careful about what you place in the DMZ. So you don't want a lot of message data lying around there, for example. And you want the product that run there to be fairly secure. So MQIPT is written in Java, which means that it's a reasonably secure programming language, by which I mean that the code running in MQIPT doesn't have access to other processes that are running on a machine, for example, unless something goes wrong with Java virtual machine. So it has security built into it in that way. To add additional security, you can run MQIPT within the Java Security Manager, and you can set the Java Security Manager configuration to only let MQIPT access the certain files that it needs to on the machine, or to access certain IP addresses, or to receive connections from certain hosts, all sorts of things like that. It controls in fairly fine-grained fashion which resources on the machine that MQIPT is able to access. And of course, you should and can run MQIPT as an unprivileged user on the system. So that again makes sure that it shouldn't be able to access anything that it shouldn't on the system. So the reason that you often use MQIPT is to move your security checks out from your queue manager a little bit outwards, possibly into the DMZ, anyway, somewhere before connections that come from the outside world get to your queue manager. And often your connections are coming in to your manager using TLS so that the messages are encrypted and secured when they're in transit. Of course, TLS is also used for authentication very often, as well as for protection of data. And so what you can do with MQIPT is to check that the certificates that are sent by the client or the queue manager that are connecting into your MQ network are valid. So MQIPT is able to check that the certificate has been issued by a valid CA, for example, one that it has the CA certificate for in its own CA certificate keyring. So it checks that. It is able to check that the certificate sent by the client is one of the ones that it's permitted to connect to MQ. So we can have a filter to only permit certificates with certain distinguished names from connecting into MQIPT on a certain route. So that makes sure that the connection is coming from someone that essentially you want to be allowed to connect into your MQ network. MQIPT can check that the certificate has been given by the client hasn't been revoked by doing an LDAP lookup. And If that's not enough, you can also write your own exit as well to perform any additional checks. All that can take place in MQIPT before the connection gets sent onto your queue manager. So it's either moving the checks outwards from your queue manager, or it's adding an extra layer of checks depending on how you configure your queue manager in MQIPT. And in a similar way, we don't look only at TLS. If we look at other properties of a connection, then MQIPT can be used to block or allow connections based on any other properties or various other properties of the connection as well, such as the channel name. So we've got an example here of a client trying to come in and connect to a route using the system def servercon channel. That's not allowed. So it's not allowed to connect onto the queue manager. MQIPT does not make the connection onwards to the queue manager. Whereas if a client connecting using the correct channel name, one that's been allowed in the MQIPT configuration, then it is allowed to connect onto the queue manager, and MQIPT forwards that connection. There's various other things that you can check, various other properties about the connection. Some of these you can set in the MQIPT configuration itself, and MQIPT will do the check and will allow or deny the connection based on that. Others, you have to write your own exit if you want to do the checking, but it's all things that you can do fairly easily in MQIPT. So something else that you can do is to restrict the types of connections that come into a queue manager through a specific MQIPT route. So you can, for example, block any clients from connecting to a certain route and only allow connections from queue managers. So as you can see in the diagram again, if a client tries to connect in through this route, it won't be allowed, but if a queue manager tries to connect, it gets allowed. Something else that you can do is to only have a specific number of connections allowed in for an MQIPT route. Now this was actually more useful in the past when there was no way of enforcing this on MQ itself. You do have a channel attribute these days which lets you specify the maximum number of servercon channel instances. So this is a little bit less useful now, but it might still be useful to have MQIPT perform a check so you don't have too many connections reaching your commander at all at one time. Something else that MQIPT does for you is to keep an audit trail of connections that come in. So regardless of whether that connection is actually accepted and is passed on to the queue manager, or whether it's blocked for any of the reasons that we've looked at so far, there will be a log record written by MQIPT that has information such as the IP address of the source and the destination and whether that connection was successful or not. And there's exits that you can write as well if you want to log any additional data to other log files. So we've looked at the case so far for using IPT to essentially add additional security to your MQ connections, or maybe at least move the place where you check the security outwards from your queue manager to somewhere a little bit earlier when the connection comes into your network. Another reason that you could use IPT is to reduce the administrative costs around having lots of different connections between lots of different MQ endpoints in networks. So whenever you have a client or a queue manager connecting in or out through a firewall to a queue manager, you need to have a firewall rule in place that allows that to happen. And of course, as the number of clients or the number of queue managers grows over time, as it tends to do, then that probably means adding additional firewall rules to allow those additional clients to connect in, or additional queue managers. If you have MQIPT in the picture, then essentially lets you have only one connection going going through the firewall. So you're down to just allowing connections to or from MQIPT to go through the firewall. So that makes your network administrator job a little bit easier. Lets your MQ network grow without having to keep adding extra rules to your firewall to allow additional connections through. And similarly, you might already have a port that's allowed to go through a firewall, and you might just be able to reuse that port for your MQ connections by putting MQIPT in between the MQ endpoints and essentially using that TCP port. We've got port 80 here that's normally used for HTTP. You can reuse that for MQIPT traffic if your network allows that. So another place that you might have an administrative headache if you've got lots of clients connecting to lots of different queue managers is with TLS certificates. Because of course, once again, as the number of clients or the number of queue managers grow over time, then you need to have more and more certificates. So if you MQIPT in the picture again, then you might be able to reduce the number of certificates that you use and therefore reduce the administrative burden of using TLS. And lets your MQ network grow a little bit easier. And very similarly to what I've already shown in the last couple of slides, you can sort of reuse existing network infrastructure to make connections going through MQIPT. So I showed fairly early on in the presentation how MQIPT is able to wrap an MQ connection in HTTP and also use a HTTP proxy server. You might already have one of those in place to go, say, outbound from your environment out to the internet, and that proxy server will more than likely be allowed to connect out through the firewall, probably on a specific port. You can reuse that infrastructure with MQIPT by wrapping your MQ connections in HTTP and using that proxy server. You will need this diagram another MQIPT at the other end to unwrap the HTTP from that connection before passing it on to the queue manager. Where you can see how in the situation you've got several connections coming into MQIPT and they're all going down to one to reuse the existing HTTP proxy server and the existing point in the firewall where it's allowed out. And so it does simplify things. And the same thing is true really with the SOX proxy as well, which is probably going to be allowed to make connections out from your environment. So MQIPT is able to reuse that. And in this case, you would not need another MQIPT instance at the other end. So there are, of course, a number of ways that you can load balance across your queue managers and so on. There's a number of load balancers out there that are fairly generic. MQIPT itself is not a load balancer. However, if you are using MQIPT, then you can, if you choose to do so, write an exit that will help MQIPT route the connections that come into a specific destination. And of course, when you do that, you're able to use the exit to choose to go to a different destination based on various properties of the connection. So you could do this for load balancing, or you could do it for some other reasons as well. And I'm not saying that IPT should be used as a alternative to any other load balancers or as part of a high availability solution, but the ability is there to use MQIPT to not always have a route go to a specific destination, but if you want to write a little bit of code yourself, and actually we do have a sample exit that can be used for routing in MQIPT provided with the product, and it's not very difficult to write. The ability is there to be able to route your connections to different destinations based on properties of that connection. And there's actually various other exits that you can write as well. If you want to customize MQIPT, to make it more suitable for the solution that you have. So you can look at information for the TLS connection, for example, that comes into MQIPT, and you could allow or block connection based on specific information that you get there from the TLS connection. You can use the routing exit, as we had in the example on the previous slide, to decide where the connection should go to. You can write additional audit records to your own audit logs. All sorts of things that you can do if you want to write additional exits for use with IPT. You write all these exits in Java, and there are a number of samples that are supplied with IPT to make it a bit easier for you to get going. Now, you might be thinking, when I was talking about all these things that IPT can do with regard to, say, allowing or blocking certain connections based on things like TLS certificates provided by the client, or maybe by based on things like the IP address where the connection is coming from, you might be thinking, well, MQ can actually do that as well. And it can by using channel authentication rules. And the reason that MQIPT can do this as well is, firstly, because MQIPT could do this before MQ could. So it's historical in a way that MQIPT had this capability before channel authentication records were added to MQ, even though they've actually been in MQ for a number of years by now. But that doesn't mean that you might never need to use this capability in MQIPT anymore. It might be that the channel authentication rules in MQ itself are all that you need, and that's fine. But it might be that some of the capabilities in MQIPT give you a little bit extra that you can't do by using the channel authentication rules only. So, for example, you get the benefit when using MQIPT to proxy your MQ traffic, essentially getting it to act as a gateway. You get the benefit of hiding all your internal network from the outside world. So you know that all the traffic that comes into your MQ network from the outside world goes through this one single point, which is MQIPT. That's the IP address or the host name that all the connections use when they're connecting in, and they don't know anything about which queue manager they're actually connecting to. And actually, that means that you can change your MQ network internally without the changes being seen externally, but it also adds security as well, because it means that there's less information available out there publicly for people to know what's actually going on inside your MQ environment, your MQ network. Also, there's the reasons I've been through a few slides ago about using MQIPT in order to simplify your network connections, maybe reuse existing proxy infrastructure. So that's essentially making the network administrator's job a little bit easier by reducing the number of connections that need to go through the firewalls, for instance, by getting them all to go through MQIPT instead. There's, of course, the very common use case as well of having MQIPT placed in the DMZ and terminating TLS connections before re-encrypting the connection and sending it on to the destination queue manager. That's something that a lot of customers do because their corporate requirements mandate that they need to do that. So they don't really have a choice about doing it, and they often find that MQIPT is a good solution to do that to the MQ connections, because it's something that is a product that's been around for a number of years. It's fully supported part of MQ itself, and it's also provided for free for all MQ users. So it's quite an attractive product for that reason, that solution. And of course, you can push your security checks outwards towards MQIPT. and away from your queue managers. Or, of course, you can have security checks on connections being made in several places. So that just adds extra layers of security. So this might be what your MQ network looks like for connections coming in from the outside world, for example, where you have MQIPT in the DMZ to block certain requests that are not well formatted, or maybe they don't have the correct client certificate associated with them. You might have another MQIPT afterwards that takes off any wrapping that's been done to the MQ connection. So it might have had TLS added to it. It might have had HTTP added to it in order to go through the firewall, in order to make the network configuration a little bit easier. That one's not essential. It depends on exactly how you're using MQIPT, of course. It's just an illustration on this slide. But in conjunction with that, you may very well also want to use channel authentication rules in your queue manager, because, of course, channel authentication rules don't just let you block connections from certain places that you don't want to connect to MQ. It lets you allow connections from places that you do want to connect into MQ, and then assign the user identifier, the user ID that's going to be used for that connection, and then that's the user ID that gets used for authorization checks for anything that happens that's associated with that connection. So channel authentication rules are still useful even when used in conjunction with IPT. So let's look quite briefly actually at how you would configure MQIPT. I've already had an example fairly early on of what an MQIPT route is. You can have, by the way, several routes on an MQIPT instance, so it can be listening on several different TCP ports for connections that come into it, and each one will have a certain destination associated with it in the MQIPT configuration. So if a connection needs to go to a certain queue manager, then that connection will probably need to come into a certain port on MQIPT, be associated with a certain route at that point, and then go on to that certain destination that's associated with the route. The connection that needs to go to a different queue manager needs to connect to a different port and then be processed out of a different route on MQIPT. And this is an example of a slightly more complicated route definition here, so than the one that we had earlier, which was very, very simple. This one has information about TLS in it as well. So this route is acting as an SSL client, which means that it's passing on information that's been protected using TLS to the queue manager destination, and it's also accepting TLS connections in as it's acting as a TLS server as well. And all this information gets stored in a single configuration file that's read by MQIPT. It's called mqipt.conf. And that essentially contains a number of route definitions. We've only got an example of one route definition in this slide. There's also a number of global properties that you can specify too, which take which affect all the routes essentially in MQIPT unless they're overridden by a specific route. And there's also some specific properties like the security manager, for example, that we have here, which affect all of MQIPT. So the security manager property that we have here says that this MQIPT instance is going to be run under the Java security manager to add a little bit extra security. Now you'll see down in the route definition where we have the SSL client and the SSL server properties, that we have keyrings that are configured for the route. So MQIPT will need to have TLS certificates that it uses when it's connecting as a client to the queue manager, or to identify itself when it's receiving connections from a client. That's when it's acting as a TLS server, and those certificates need to be stored in keyrings. So MQIPT needs to have keyrings, and it also needs to have the passwords for those keyrings stored in its configuration. So you'll see that we have a few properties there that are ending in PW, so those are the passwords for the keyrings. those passwords all need to be encrypted because they're in the configuration file. The file system permissions are not enough on their own, obviously, to make entirely sure that those passwords can't be seen by people who shouldn't be seeing your passwords. So we do have a tool available called MQIPT PW, which is used to encrypt any passwords that you stick in the MQIPT configuration file. Now, up until MQ 9.2, there was a GUI available which would help you essentially configure MQIPT, change the configuration for several MQIPTs actually that it was connected to. We don't have that option available anymore. It wasn't very widely used. So your only way of configuring MQIPT at the moment is to use a configuration file. But it's really quite easy. It's just a text file containing a list of properties. And once your MQIPT is running, there's a command called MQIPT admin, which you can use to administer it. And actually the actions that you can do, or the actions that you need to do on a running instance of MQIPT are only, they're very small, they only refresh the MQIPT instance, which means that once you've made a change to the configuration file, you want to bring the changes into effect without having to stop and restart MQIPT. You run the refresh command to do that, or you might want to stop MQIPT. Those are simply the two actions that you can perform to administer MQIPT. Now, the way that those commands get received by MQIPT was, this is something that's changed in MQ 9.2 actually. In the past, there was only one way for those commands to be received by MQIPT. So for the commands to be transmitted essentially from where you issue the MQIPT admin command to where the MQIPT hook is running. And the way that was, the one way that could be done prior to MQ 9.2 was by using what's known as a command port, which is that the MQIPT instance would listen to a specific TCP port for a connection from the MQIPT admin command. Now, unfortunately, that wasn't very secure. Not just because there was very little security around the port, but of course because you might be running MQIPT in the DMZ, for example, and many customers have some rules which say that they just can't have something listening for commands on a network port in the DMZ. So that was a little bit of an impediment to using the MQIPT admin command to administer MQIPT in previous versions. From 9.2 onwards, you now have the ability to, first of all, connect directly to local instances of MQIPT that are running on the same box as the MQIPT admin command. You can do that without using a command port. So that's a big improvement, I think, to how you can administer MQIPT. Or if you want to connect to a remote instance of MQIPT, there is also a command port which is now secured by TLS. So in 9.2, we've made the administration of MQIPT a lot better, I would say. Hopefully, that's convinced you that MQIPT is something that might be useful for you and is worth looking at. So if you do want to get hold of MQIPT, you can get the latest version, which is 9.2 from Fix Central. Remember, as I said at the beginning, although it is now officially part of the MQ product, it's still a separate download and a separate installation. So Fix Central is where you go to download the MQIPT installer from. It's available on the Linux, AX and Windows platforms that are supported by MQ itself. So that's another benefit of bringing MQIPT into the MQ product, is that it's now available on the same versions, supported in the same versions of those operating systems as MQ itself. Now, bear in mind that the MQIPT support pack has now reached end of service. So that's version 2.1 of MQIPT. And it reached end of service at the end of September this year. So if you're using that, then I'd urge you to migrate up to MQIPT 9.2 as soon as you can. The service lifetime of the MQIPT support pack was actually, it was always tied to the service lifetime of MQ version 8, and that statement was on the support pack website for a long time. We actually extended the lifetime of the support pack by a little bit till the end of September this year to try to give people some time to migrate up to IPT 9.2 after the LTS release had come out. So I've already mentioned a number of the recent enhancements that we made to IPT since it was integrated with MQ. So those would be the administration improvements in 9.2. We have made a number of other improvements since IPT was integrated with MQ in 9.4. So for example, we've upgraded the JRE to Java 8, so it's now using the same JRE as MQ itself. And that JRE comes with MQIPT, and it's essentially part of the installation. We also added support for PKCS 11 hardware, so that's essentially using hardware HSMs to store the TLS certificates that are used by MQIPT. And we also improved the protection of passwords that are stored in the MQIPT configuration. That's essentially adding better encryption for passwords that you encrypt with the MQIPT PW command in order to store them in your IPT configuration file. So that is actually all that I had to say about MQIPT. So I finished 10 minutes early, which is nice. So I'm happy to take any questions if anyone has any. Otherwise, please submit your feedback. And I hope that you enjoyed this MQ session as well as the other MQ sessions that have been part of this conference.
Thank you very much, Gideon. It's been a blast for a couple of weeks. I think the whole conference has been a mighty success. And I'm sure Mark will say that in his wrap-up session at 5:30. And thank you very much for your team's effort in the past 2 weeks. It's been brilliant.
Yep, thank you, Mel. I think the conference has gone very well, and thank you to everyone who's joined us over the past couple of weeks to listen to the sessions.
Right, thank you. Don't forget the feedback form, and let's hope we can meet face to face next year.
Yeah, so look forward to that.
In lovely Wales. Okay, bye everyone.
Thank you. Bye now.
Bye.